These two companies are the only companies that make this amazing chip we talk about, called the central processing unit or the microprocessor.
Hi, my name's Erica Gomez, and I'm an engineering manager at Amazon.com. One of the best things about working in tech, and at Amazon in particular, is that I get to bring my dog with me to work every day. My job is to help make sure software gets out the door, and her job is to nap under my desk and snore very loudly.
My name is Jerome Holman, and I'm a program manager on Team Xbox, and I have a really fun job, basically bringing the hardware and the software together to give you all the games that you love on your Xbox.
When you look inside a computing device, you see a bunch of circuits, chips, wires, speakers, plugs, and all sorts of other stuff. This is the hardware. But what you don't see is the software. Software is all of the computer programs or code running on this machine. Software can be anything from apps and games to web pages and the data science software that me and my teams use at Amazon to understand how customers behave. But how do the hardware and the software interact with one another? Let's start at looking at a computer's central processing unit, or CPU.
The CPU is the master chip that controls all the other parts of the computer. A CPU needs to do different things, so inside it has smaller, simpler parts that handle specific tasks. It has circuits to do simple math and logic. It has other circuits to send and receive information to and from different parts of the computer. The real magic of the CPU is how it knows which circuits to use and when to use them.
The CPU receives simple commands that tell it which circuit to use to do a specific job. For example, an add command tells the CPU to use its adder circuit to calculate a new number. And then the store command tells the CPU to use a different circuit to save that result into memory. Just like numbers, all of these simple commands can be represented in binary ones and zeros, or on and off electrical signals. The binary commands are stored in memory, and the CPU fetches and executes them in sequence, one after the other. This sequence of commands is in fact a very simple computer program.
Binary code is the most basic form of software, and it controls all the hardware of a computer. These days, nobody writes software in binary. It would take forever. Today, the software we write looks more like this, or even this. Programming languages like these let you type in commands in something that looks a lot like English. To draw a rectangle on the screen, you just need a single command. This high-level command is converted into hundreds or thousands of simpler binary commands that the CPU understands.
Software tells the CPU what to do, but when you're listening to music and browsing the web and chatting with a friend, your computer is running multiple pieces of software all at once. So how do all of these programs get on the computer in the first place, and how can the CPU run them all at once? To find out, we'll have to take a look at the operating system.
The operating system of the computer is the master program that manages how software gets to use the hardware of the computer. For example, I helped create the Windows operating system that runs on most personal computers. The operating system is a program with special abilities that let it control the other software on the computer. It lets you install new programs by loading them into your computer's memory. It decides when a program is run by the central processing unit and whether that program can access the computer's input and output devices. And when you think your computer is running many programs at once, in reality, it's the operating system that's quickly switching between programs, sharing that CPU for fractions of a second.
Inside every computer is an operating system managing software that controls the computer's hardware. The software is a series of commands made of simple binary code, and that binary code is just electrical signals flowing through billions of tiny circuits.
Computers have the potential to do all kinds of amazing things. But the only thing that makes a computer smart or useful is you. When you learn to code, you get to define the problem you want to solve and write the software that turns those ideas into reality. That gives you the power to build things that matter to you, your community, and the world.
All right, so we are still learning about the components of the computer system, and we've been able to look at the computer case, the motherboard, the power supply unit, and now we want to learn about the CPU. We learned that the computer hardware has 8 core components and peripherals, and the core components we learned about are the case, the motherboard, power supply unit, and the CPU. So today we are going to deal with the main central processing unit. The CPU is called the microprocessor, or the processor, or central processor, or main processor, or the central processing unit. It is the brain of the computer. It is the brain of the computer. Its function is to calculate every command that runs on the computer. It is one of the most important components of the computer system. Sometimes when we say it is one of the most important components, it is an understatement, because the CPU is not just one of the most important components, it is the most important component. Without a CPU, you don't have a computer. And as a matter of fact, the CPU is the computer. Every other component is there to help the CPU do its work, because the CPU is what does the computing, the computation, and all the processing and operation in a computer. When you want to grade a computer, you grade a computer by its CPU. The CPU in your computer is what tells how good your computer is, how strong and how powerful your computer is. When you take a laptop or a desktop, you are always going to see a sticker on it. The sticker will tell you about the CPU in that machine. There is always a sticker. Sometimes you buy a laptop and it's written Intel Core i5 or Intel Core i7 or Intel Core i3 or AMD. The i5 you see on the laptop is not just telling you how good the laptop is, it is talking about the CPU in that machine, because the CPU is the i5, the CPU is the i7. And when you see an i7 machine, you already know that it is powerful. You don't even have to check the rest. When you see i7, you know that this is a super machine. Today, we've even had the i9. Intel has released the i9. When you see a laptop and the sticker on it is i9, you don't have to check any other thing. It is good, because the i9 is the latest CPU from Intel. When it comes to computers, and when I say computers, I'm talking about desktops and laptops, there are only 2 manufacturers of the CPU. I want to repeat that. I didn't say there are only 2 computer manufacturers in the world, because we have so many computer manufacturers. We have Dell, we have Toshiba, we have Acer, we have Samsung, we have Lenovo, we have so many computer brands out there, right? But what I'm telling you is that when it comes to CPU, the CPU inside of the computer. It is only two companies that make them. These two companies are Intel, AMD. Intel and AMD. These two companies are the only companies that make this amazing chip we talk about, called the central processing unit or the microprocessor. Intel and AMD. That means when a company like Toshiba wants to make a laptop or desktop, they have to visit these two companies, one of them, and buy CPU from them. Every Toshiba laptop is having either Intel or AMD. Every Samsung laptop is having either Intel or AMD. Every HP laptop is having either Intel or AMD. Because these are the only two manufacturers of the central processing unit. The latest chip or CPU produced by this company is the Intel Core i9. And the latest CPU produced by AMD is a AMD Ryzen. Let me give you a little bit of difference between Intel and AMD. Intel CPUs are more advanced in terms of high intensive processing and logical operations for business, education, programming, and high intelligent works. Let me put it that way. Intel CPUs are expensive and powerful. Let me put it that way as well. Now, all the attributes and adjectives I've given about the Intel CPU does not mean AMD is not good. AMD is powerful in their own way. AMD specializes in gaming and entertainment. So if you are looking for a PC for gaming, multimedia, entertainment, the best computer to get is the AMD computer, or a computer with the AMD sticker, or a computer with the AMD CPU. AMD machines are mostly designed for gaming, multimedia, entertainment. The best machines for computer games are AMD machines. The best machines for videos and music and cinema and anything entertainment is AMD. AMD CPUs are low cost. They are not expensive. Because of that, when you want to buy a computer and you see the sticker on the laptop or desktop, that alone should give you a clue about price and a clue about the type of machine. If you are a student and you want to use your laptop for school, learning, you need a machine from Intel. If you are someone who does computer programming and computer graphics and you use your laptop for business and work, you need an Intel computer. But if you are someone who only uses your laptop for videos and music and games, then you need an AMD. Intel CPUs have high performance in terms of intelligent and high-level processing than AMD CPUs. Nevertheless, modern AMD CPUs are bridging the gap. Despite all that I have said, I'm saying that modern AMD CPUs are bridging the gap. In some few years, the explanation will change. The differences will change. But this is what is general out there. Have you ever seen a laptop with some stickers on it before? Let me tell you, every laptop should have a sticker. Unless it's an Apple computer, every laptop should have a sticker. If the sticker is not there, it means someone has removed it. Now, anytime you see a laptop, the first thing you want to see, that's the first thing you want to see, is a sticker from either Intel or AMD. You have to find that. Now, this laptop, is it having Intel or AMD sticker? Intel. Okay, so there are a number of stickers on them. They all do different things. But this one is what I'm interested in for now. And I see Intel Core i5. Is the Core i5 visible to you? Can you see this? Please, can you see this? Can you see this? This is the sticker I'm talking about. This alone tells me how much the laptop should cost. Alone. And it tells me what I can use the laptop for. And it tells me the grade of the laptop in terms of performance. I see Intel Core i5. When it comes to Intel, their modern CPUs are the Core i3, Core i5, Core i7, and Core i9. The i9 is the latest from Intel. This is a computer case, a system unit. Every system unit should have a sticker. When I see this system unit, I know that it is from Intel, right? How about this system unit? I know that it's from where? This is AMD. When you see any desktop computer or laptop computer, no matter the brand, as in the manufacturer, the CPU should either come from Intel or AMD. Because these manufacturers work with both companies, and these two companies are the only manufacturers of CPUs. A computer cannot have both Intel and AMD. It is not possible. Are you with me? The CPU in a computer cannot be both Intel and AMD. It is not possible. And you cannot remove an AMD CPU from a computer and replace it with Intel. It is not possible. Because when a CPU is designed for AMD, it is only compatible with AMD. What did I say? When a computer is designed for AMD, it is only compatible with AMD. When a motherboard is designed for Intel, it is only compatible with Intel. Are you with me? Over here we can see AMD Radeon, or AMD with their Radeon graphics. And this is another sticker from AMD saying this is Ryzen 7. So when it comes to the Ryzen, we have Ryzen in different numbers. So this is the Ryzen 7. When I look at this system, I know that this is Intel number 1, and I know that it is Pentium D that is inside. Have you seen Pentium D? This Pentium D already tells me that this machine is old. It's not a modern machine, because Pentium D was released somewhere I think it's more than 10 years old, or even more. The reason why, now I can check, okay, all the Intel CPUs, you can check their release dates. Today the modern ones are the Core i series, the i5, i3, i5, i7, i9. Are you with me? Another reason why I said this is very old is because of the second sticker here. I'm seeing that it is designed for Windows XP. Wait a minute. Do you know when we used to use XP? Now, most of the time, there will be a second sticker about the operating system in the computer. And when you see that there's a machine designed for Windows 10, you should know that it is a machine that is modern. When a machine is designed for Windows 7, like this one, you see that the sticker is Windows 7. Okay, I can say that it is not very modern, but it's okay, because Windows 10 was released 2015, and modern machines made after 2015 should be made for Windows 10. So a Windows 7 sticker here, that also tells me that, and it gives me an idea. But when you see something like Windows XP, this is very old. So Pentium D should be very old. I think should be more than 20 years even. We are still talking about the central processing unit.
Hey, what's going on? Very glad to see you back here on Tech of Tomorrow. You guys should know by now, I'm Elric, your host. Now, one of the biggest questions that I get every day of the week is, what's my choice? AMD or Intel? What's better? What should I do? How and why should I make a decision like this? Well, AMD and Intel both make CPUs. Now, AMD, since they bought ATI, they also make GPUs as well. So in some ways, as a total package, AMD has some better leverage over Intel. Now, the main thing is you have to ask yourself, what am I going to be doing? That's the first thing you got to ask yourself. What are you doing with your computer? Because if the only thing that you're going to do with your computer is watch games at 1920 by 1080, there is absolutely no reason in the world that you can't use an AMD system. Even one of their Trinity APU systems with a 6670 will still play a lot of games at decent frame rates, even with a 6670. That's a very cheap system. You can put a whole system together like that for very low priced. Now, with that said though, if gaming isn't the only thing you're doing, and when I say gaming, I pretty much mean gaming, internet surfing, typing documents, any of the basic type stuff, but your fun factor is gaming. There's nothing wrong with AMD. Now, if you're a person though, you're going to be rendering in 3D. You're going to be using a lot of type of stuff like Photoshop, high intense math calculations and those kinds of operations, you're going to want to go with an Intel based system. I mean, there is a reason why Mac only chooses to use Intel in their systems and not AMD. When it comes to high tech stuff, Intel is just better. They have less problems, they have less errors, just overall for high end calculations, they are very good. Now, on the server side of things, There are all kinds of great AMD servers that are out now that'll totally work with our Opteron and other type of things. So in the server market, from what I'm hearing from the people out there, I'm not a big server guy, but in server market, even though Intel definitely has the lion's share of the market, hey, AMD still has some great solutions. So at the end of the day, a lot of people always ask this, what's better? It really just depends on what you're going to be doing. Now, I've bought a bunch of different laptops. For laptops, due to heat and the very fact that there's always more heat with AMD CPUs, that's one of the big things about them right now. Intel has cooling off things with the laptops. I pretty much choose to go with Intel. With their HD 4000 graphics on their new stuff, they seem to work very well for those type of basic applications. You know what I'm saying? But you don't have to go out and spend big money on an Intel CPU and all this stuff if you just want to do basic things. The Intel CPU comes into play when you're doing things much beyond standard gaming. If you're just gaming, doing standard stuff, I have to say you should probably be looking at AMD unless you just have an enormous amount of money to spend. And in some cases, when we're comparing stuff, even with using an NVIDIA card and Intel versus AMD and AMD, on some of the gameplay, we've heard and we've seen from all their sites looking around that sometimes you get better performance. That's just the way that it is. So if you're somebody out there and right now you're sitting ready and you're going, hey, I'm going to go out and I'm going to buy a system. First off, determine what it is you're doing with your system. Determine your budget. And then pick the parts that you want to go. There's all kinds of great things. And nowadays, pretty much all parts are almost plug and play. There are some people who have some extreme stuff that has problems with drivers and stuff, but almost even the most non-PC person can go out and buy a bunch of parts and put them together and it should work. So do it yourself, guys. You can save a lot of money by going out and building your own PC. So at the end of the day, when it comes to AMD versus Intel, there is no clear winner. Because sure, you can say that an i7 that costs $1,200 gets you a little bit more frame rates than a CPU that only costs $85. But let's see here, $85, $1,200. Big difference there. And does that money difference justify the cost? Because the cost difference is major. For the longest time, I ran only Intel-based systems, but then we started doing a lot more experimenting. I started getting into the more AMD stuff, started playing around with it, and I found that a lot of these lower-end AMD systems play games absolutely fine. There's no problems. You save a lot of money. Now, if I'm doing something where I'm doing hard work, I'm going to be doing a bunch of editing and all that type of stuff, well then yes, I would definitely go with an Intel-based CPU. So there you guys have it. That's the main question I get all the time. I hope this answers some questions for you guys. If you have more, you can always put comments below, or you can send me a direct question right through the messaging here, or you can send me a direct email at elric@techoftomorrow.com. But I hope this clarifies some stuff. So if you're out there looking, no, there's really not too much of a difference, just depending on what you're doing. Like usual, I hope you guys like this video. Please hit the like button and show me that you do. It'll make me think about doing more videos of this type. And if you're not subscribed, I hope that you would be so you never miss out on anything that's going on here on Tech of Tomorrow.
The CPU, or Central Processing Unit, is also called the processor. It is the brain of the computer, and it performs all the arithmetic and logical operations in the computer. Let me take you to another dimension of the CPU. Hello. The CPU is made up of two parts. I'm taking you to another dimension altogether. Right now, I've talked to you about the manufacturers of CPU, and I said the two manufacturers are Intel and AMD. You will choose which CPU you want to use based on how you intend to use your computer. If you're a student, which CPU should you choose? Intel CPU. Alright. If you're a gamer, which CPU should you choose? Just like we went into the motherboard to learn certain things in the motherboard or on the motherboard, I'm taking you deeper into the CPU a little bit to talk about the two parts of the CPU. The CPU is made up of two parts. We have the CU and the ALU. Please repeat after me. We have the CU and ALU. Now, CPU stands for what? Now we are learning that in the central processing unit there are two parts. One part is the CU and the second part is the ALU. The CU stands for the control unit. Control unit. Control unit. The ALU stands for arithmetic and logic unit. Arithmetic and logic unit. This is what you shouldn't forget about the CPU. The CPU is made up of two parts. We said the first part is the CU and the second part is what? The ALU. CU stands for what? And ALU stands for what? Excellent. Let's continue. The CU, which is a control unit, is responsible for controlling communications. So it controls communications between the CPU and all other components of the computer system. Wait a minute. The CPU communicates with the RAM, communicates with every single component connected to the computer. The part of the CPU that controls communication is the CU. Hello. The part of the CPU that controls communications between all the parts of the computer system is the control unit. Is that clear? There's another part of the CPU called the ALU. And the ALU stands for arithmetic and logic unit. Sometimes you hear arithmetic logic units without the end, but it's best to put it this way. Because the CPU does both arithmetic and logical operations. And the part of the CPU that performs all the arithmetic calculations and logical operations in the computer is the ALU. When we say the CPU does processing and calculations, the part of the CPU that does that work is the ALU. And the part of the CPU that talks to other components is the CU. Let's take a pause and think about something. Why do we call the CPU the brain of the computer? What do we use brain for? As humans, what do we use our brains for? We use our brains for thinking. And what? We use our brains for calculations. When I ask you 2 plus 2, will you calculate it? Which part of your human system will you use for that calculation? It's your brain, right? Hello. When we say the CPU is a brain of the computer, we are not trying to tell you that that is where information is stored. We are not talking about the memory or the storage, because the CPU doesn't really do that. It does small part of that, but it doesn't really do storing. So when we call it the brain of the computer, we are talking about the calculations. the mathematical calculations, because as humans, that is a part of our human system we use for processing and calculations. It is our brain. That is why we call the CPU the brain of the computer. When you say the CPU is the brain of the computer, you are not wrong at all. Are you with me? It is safe to say the CPU is the brain of the computer, because for what it does, it is the brain of the computer. The next time I ask you about the CU and the ALU, will you be able to tell me something? When you are doing your presentation and you take the motherboard and you remove the CPU, after talking about the CPU sockets and all that, when you take the CPU, you have to tell us that the CPU is made up of two parts. We have the what? The CU and the ALU. The CU does what? Controls what? Because it's called a control unit, right? It does what? It controls communications between the CPU and all other components of the computer. And the ALU, which stands for what? Arithmetic and logic unit, does what? Arithmetic calculations and logical operations in the computer. Wow. Whenever you break the CPU down into CU and ALU, it means you've gone a step higher. It means you are talking like someone who is educated. Because the most basic person doesn't know anything about CU and ALU.
What is the CPU? CPU stands for Central Processing Unit. The CPU is the brain of the computer. It sits on the motherboard. It is made up of two parts, the control unit and the arithmetic logic unit. The arithmetic logic unit, or ALU, performs mathematical and logical operations. The control unit is the working part of the CPU, and is the part that controls the components of the PC. The central processing unit performs a fetch, decode, execute cycle to process data. To break it down, the fetch part of the cycle is basically where the CPU fetches data from the main memory and then stores the data from the main memory in the CPU registers. A register is a temporary storage area which can hold a single byte of data. They have two wires, a set wire and an enable wire. The program counter copies the address of the next instruction it contains into the memory address register, MAR. Then, the memory address register triggers a read signal that causes the main memory, RAM, to place the instruction being asked for onto the data bus. The data bus and the address bus both consist of a set of 8 wires, one for each bit. The instruction on the data bus is loaded to the memory data register, also called the memory buffer register. The memory data register copies the instruction into the instruction register, completing the fetch stage. Next is the decode section. The CPU examines the instruction in the current instruction register and decodes it. This basically means that the CPU will be able to understand what the instruction is. An example is that the instruction might say add. The CPU will decode it to understand what it means and prepares to carry the instruction out. The final stage is the execute section. This is where the CPU will carry out the instructions within the instruction register. Once that instruction has been executed, the cycle starts again from the start for the next instruction.
When it comes to CPU, we've learned about its function, we've learned about the manufacturers, we've learned about the CU and ALU. Are you here? Now we are moving to a subtopic that we call the clock speed. The clock speed. Say that after me. The clock speed. The clock speed. All right. Let me explain the clock speed before we read about it. Listen to me carefully. When we say computers are fast, computers are super fast. Faster than the blink of an eye, faster than you can imagine. Faster than you can even assume or think about. When I tell you to go wild and think of something fast, you can't even think of how fast the computer is because it is faster than what you can imagine. And I'm going to explain the speed of computers. The CPU is what determines the speed of a computer. Hello. The CPU is what determines the speed of the computer. What determines the speed is not the RAM. Even though last time we said RAM can make your machine faster. RAM is not what determines the speed. The hard drive or SSD is not what determines the speed. They can contribute in other ways. But what determines the speed of a computer? When you take a computer and you say, wow, this machine is fast, it is the CPU. Because every CPU has a clock speed. And CPUs are rated by their clock speed. If I want to compare CPUs, one of the things I will compare will be the clock speed. Clock speed can also be referred to as frequency or the speed of the CPU. Let me tell you the units in which clock speed is measured. Clock speed or frequency is measured in hertz. It's measured in what? Hertz. Have you seen this before? Hertz. I'm not talking about centimeters. I'm not talking about millimeters. I'm not talking about kilogram, milligram. I'm talking about what? Hertz. If you know anything about hertz, you know that hertz is interesting because hertz means, let me tell you the meaning of hertz. Hertz stands for what? Hertz stands for what? Anytime you hear hertz, it means cycles per what? Hello? Anytime you hear hertz, it means what? So, without giving you further explanations, if I say 2 hertz, what does it mean? When I say that something operates in 2 hertz or has a speed of 2 hertz, what does it mean? I've already told you the meaning of hertz. So when I say something has 2 hertz or operates in 2 hertz, what does it mean? I need someone to answer this question. 2 what? Excellent. So 2 hertz, this is the abbreviation of hertz, HZ. When you see anything that operates in 2 hertz, it means it operates in 2 what? Do you get it? And when I say 2 cycles per second, what does it mean? It means in every second it can run 2 times. Cycles per second. So when I say it is 2 hertz, it means it runs 2 times in a second, right? Okay, I'm going to give you another one. When I say something operates in 300 hertz, what does it mean? Or operates at 300 hertz, what does it mean? Pardon? I can't hear you. 300. You are right. And what does that mean? What does that mean? I know we are talking about speed. Anytime you hear hertz, it's about speed. But what we've written here, you said 300 cycles per second. What does it mean? Break it down for me. When you tell someone 300 cycles per second, what are you trying to say? Exactly. That means in every second, 1 second, it will run how many times? Wow. Wait a minute. Oh. Do you know what 1 second is? I sure you know second. I'm not talking about minute. I'm not talking about 1 hour. Second. I sure you know 1 second. Eh? How fast is 1 second? Eh? Someone will say K. That's all. That's 1 second. 1 second is what? K. Again. That's 1 second. What in the world can run 300 times in just 1 K? 1 second. Okay, wait a minute. Computers are way faster than this 1,000 times and 1,000,000 times. Wait a minute, I'm about to explain. When you hear of 1,000 hertz, what does it mean? Right? 1,000 cycles per second. All right. Now, this is very fast. Wow. Now, wait a minute. Instead of saying 1,000 hertz, in IT, anything in 1,000, we have given it a name. So instead of saying 1,000 hertz, I will just say that this is equal to 1 kHz. That means 1 kilohertz, right? This is the same as 1,000 hertz. Please don't be confused. Are you here? 1,000 hertz is the same as 1 kilohertz because 1,000 means kilo, or kilo means 1,000. When you hear kilometers, it means 1,000 meters. Are you with me? When you hear kilograms, it means what? 1,000 grams. When you hear kilohertz, it means what? 1,000 hertz. When you hear kilobytes, it means what? 1,000 bytes. Are you with me? Okay. Now, let me tell you. Even when computers started, no computer operated at 1 kilohertz. 1 kilohertz is too slow for computers. Wait a minute, do you know 1 kilohertz? 1 kilohertz technically means 1,000 cycles per second. If there is something that runs 1,000 times in 1 second, is that thing fast? If something can run 1,000 times in a second, is it fast? Yes. Of course it's fast, but this does not measure to the speed of computers. This is nothing. When computers started, they were not even running this slow. How much more today? Wait a minute. If I give you, this is 3 zeros, another 3 zeros, and I say hertz. Let me close the zeros now. Now you have seen the number of zeros, right? Okay. I can use comma to separate them. What have I written here? What is this? 1 million hertz, right? 1 million hertz is the same as 1 MHz. That is 1 megahertz. Please, are you with me? And this means 1 million cycles per what? Hold on a minute. 1 million cycles per second. No, wait a minute. Is it possible for something to run 1 million times in 1 second? Computers do much better than this. I'm going to tell you how fast computers are. Computers operate or processes more than 1 megahertz. 1 megahertz, you can't even think about it. Let me make it much better for you. When you see this, who can mention this? What is this? We said this is 1 million, right? What is this? 1 what? 1 billion, and this will be referred to as gigahertz. Have you seen this? 1 billion cycles per second. Now, when you talk at this level, you have now gotten to the area of computers. If they tell you that something runs 1 billion times in 1 second, that is unimaginable. Wait a minute. Not 300, not 1,000, not 1 million. The average computer today, runs at 2 gigahertz. 2 billion cycles per second. And this gigahertz is the clock speed of CPUs. I'm not saying all CPUs are 2 gigahertz. What I'm saying is that this is the average. I hope you understand average. Alright. So some may be less, some may be more, right? So you can find some machine that is 1 point something. You can find some that are 2 point something, some that are 3, some that are 4. But in general, the average one is like 2 gigahertz. That is for PCs, personal computers. Now let's read what we have here. Clock speed. The CPU is the main component that determines the speed of a computer. Every CPU has a clock speed, which is measured in what? Gigahertz. Hertz stands for cycles per second, and the average CPU today runs at 2 gigahertz. That means 2 gigahertz per second, which means 2 billion cycles per second. So this is a clock speed. When you check any machine and you see this PC, can you see this PC? You can right click on this PC and go to properties. Are you with me? Are your machines off? Alright. Then let me talk about something else about the CPU before I open to this. Now, I want you all to get your machines on. But then let me talk about something else first before I show you mine. When you are presenting on the CPU, you need to tell us about the function of the CPU. You need to tell us about the manufacturers of CPU. You need to tell us about the 2 parts of the CPU. You need to tell us about the clock speed of the CPU. If you don't mention these things, then you have not talked about CPU. Another thing you cannot skip when you are talking about CPU is the next thing we are going to talk about, which is what? Number of what? Number of what? I said, whenever you are talking about CPU anyway, talk about the function of the CPU, talk about the manufacturers of CPU, talk about the 2 parts of the CPU, talk about the clock speed of the CPU, Another part that you cannot skip is the next one, which is what? The number of what? What I'm going to say here is that when CPUs started, they were all manufactured with what? When CPUs started, they were all manufactured with single cores, right? Today, CPUs are manufactured with what? Today, CPUs are manufactured with what? Multiple cores. I want to tell you what this means. Before we understand this, we need to understand what a core is. Hello, are you here? A core is the what? Main processing unit within a CPU. And I'm going to explain it to you. Please, are you here? Please, are you here? At the heart of every CPU is a core. The core is the main processing unit within the CPU. Hello? Have you ever studied the anatomy of the Earth? And you know that the Earth has several layers. Those of you who just completed high school, you know the layers of the Earth. Who can mention some? We have the what? Please. We have the crust. We have the what? The mantle. And we have the what? The what? The core. Didn't you study about the Earth? This is where we live. Hello? This is where we live. You know that? We live on the earth, right? Now, when you go inside, now you know the earth is spherical. When you go in the earth, we have the crust at the surface. Then the next layer is called what? Then the inner layers are called the core, right? Hello? One day someone said we live inside the earth. Hey, babe. We don't live inside the earth. Though. Where do we live? We live on the surface of the earth. So we are here. Our houses are outside. On top. If you go inside, you die, please. Because we have volcano inside. You know volcano? Please. See. Do you see this thing happen somewhere? Volcano came out of the earth and it started destroying things and killing people. Volcano is liquid fire. Please, have you seen this? Listen, when a drop touches you, you die. This is liquid fire. This is what is in the earth. So where we are, the earth you are standing on, if you go in the middle of it, the inner part of it, it is liquid fire. That is what is in the core of the earth. Sometimes they spill out. Sometimes they create mountains, sometimes they create metals, sometimes they create a whole lot of things. If they spill at the wrong place, everyone will die. When it touches you, even your bones will not be recognized. Your bones will evaporate, will vanish. Please watch this. Can you see this? This is not fire like you know. This is liquid fire. Fire like water. That's what is coming out. This is not the fire, the gas fire or the fire you know. Sometimes when they heat gold, have you seen gold being heated in that fire before? Then it becomes liquid. Then they pour the gold to create different things. Even when they are making swords, you see that they burn metals into liquid. You've seen that before. That's how this one is. That's how this is. Alright, enough of this. Hey, why are people close to it? Have you seen that thing? Hey! So this thing, when it dries, it will become a mountain. Hey, these people. Hey. Have you seen that thing? Anyway, enough. So inside the earth there's a core. The core is the inner part of the earth. That same way, CPUs also have cores within them. I'm not saying they are like the earth core, but there is something within the CPU called the core. Are you with me? And the core is the main processing unit in a CPU. Let me explain it this way for you to understand. Let me tell you. Today, CPUs are manufactured with multiple cores. Did I tell you that? Yes. If a CPU has 2 cores, let me tell you what will happen. It is just like putting 2 CPUs in one computer. That is what it means. Listen to me again. If a CPU has 2 cores, it means, or it is just like placing 2 CPUs in one computer. That is what it means. If a CPU has 4 cores, listen to me, it is just like placing 4 CPUs in one computer. Wow. What will happen if there are 4 CPUs in one computer? That means first, the computer will be very fast. First of all. Number 2, processing will be shared among the 4 CPUs. And each one can be processing different things at the same time. And so the computer can run so many applications at the same time. That is what it means. But what I want you to understand is that CPUs with multiple cores are not multiple CPUs, but the multiple cores are built onto the single CPU. So we have CPUs today. Okay, have you seen this picture here? Can you see this picture here? This picture we are seeing here is telling you that this is a multi-core CPU, and there are 2 cores in this CPU. Please, can you see this? Hello. It means this CPU, even though it is one CPU, the core within it are two. And so we call this CPU a dual core CPU. Have you ever heard dual core before? When talking about computers, have you ever heard someone saying that this computer is dual core? Or you've heard the phrase dual core? Dual core means two cores. Hello. All right. Today we have computers with not just two cores. This is a diagram of a CPU, a certain CPU. How many cores do you see? You see 4 cores. What it means is that this particular CPU is made with 4 cores. If you have a CPU that has 4 cores, it means your computer can do multitasking. Computer can do what? Multitasking. That means it can run several applications at the same time. Let me use this analogy to explain it. Let's say you have been tasked to prepare jollof rice with chicken and salad and stew. Hello. Are you hungry? You have been tasked to prepare jollof rice with chicken, salad, and stew. And you have just one cooker or one burner. Do you know it will take you a long time to finish cooking? If someone else is preparing the same thing with a gas cooker with 4 burners, what will happen? That person will be what? Faster, right? Because why would that person be faster? Or why would that preparing that with that kind of cooker will be faster? Why will it be faster? Or how? Exactly. So several things can be cooking at the same time, right? Let me tell you, this is exactly how CPUs with multiple cores work. Several applications can be running at the same time. In IT, we call this multitasking. Today, CPUs are manufactured with multiple cores. Each core represents a single processor. A CPU with 2 cores is known as a dual-core CPU, whilst a CPU with 4 cores is known as a quad-core. So keep that in mind. When you hear quad-core, it means 4 cores. When you hear dual-core, it means what? 2 cores. Is that okay? All right. So in talking about the CPU, I said you need to talk about the function of the CPU. First of all, the definition and the function. Then you talk about the manufacturers. You talk about the CU and ALU. You talk about the clock speed, and you talk about the number of cores. If you don't mention these things, you have not explained the CPU.
Welcome to Dell Tech Support. Processors are all about speed, but what else is there to know about them? In this video, we'll explain what a processor is, how it works, and what its main features are. The processor is a chip responsible for calculations. It makes all the logical decisions, which are basically all the tasks your computer does. From the simplest thing as opening a window to the most complex, like completing a 3D animation. For this reason, the processor is known as the brain of the computer. To understand how it works, imagine this scenario. We have a processor, and next to it there is memory RAM and inputs coming from the output devices: your hard drive, mouse, keyboard, and monitor. The mode of communication between them is called the motherboard. It is responsible for linking the processor to all the components of your computer. The processor executes three basic functions: receive input data, process this data, and provide output data. But what exactly does all this mean? When you type in some text, for example, each letter entered is input data. The processor receives this data, processes it, and provides the output. In this case, everything that you type will appear immediately on your screen. All this is done in a fraction of a second. There are other types of processors too, which may be installed on your system, but every processor contains several important features. Here are the main ones. The socket. The socket is a type of physical connection between the processor and the motherboard, and it is responsible for transmitting energy to the processor. The core. The cores are responsible for the processing speed. The more cores a processor has, the more functions it can execute simultaneously without overloading your system. The clock. The clock is responsible for defining the frequency that your processor will use to execute one task. It's measured by hertz. This means the amount of cycles that can happen in a given amount of time. In this case, in seconds. For example, if a processor has a 2 GHz clock, it can have up to 2 billion cycles per second. So the higher your clock frequency is, the lower the execution time will be, which for you means a faster processor. The cache. Basically, the cache is the auxiliary memory of a processor where the most accessed data that will be processed is identified and then stored. The processor accesses this memory and is able to execute the action faster because it's more readily available. This is one more important factor that has a direct impact on the processor speed. The more cache there is, the more quick storage capacity you have, which results in a faster speed. If you have any questions or need help, contact our social media support through Facebook or Twitter. Thanks for watching, and be sure to check out other tips and tutorials on this channel. See you next time!
This brings us to the end of our studies on the CPU. Next time we'll continue with other components.